polyhedron is a three-dimensional figure made up of polygons. So if you remember, polygons don't have any curves. So a polyhedron has no curves either. All of the sides will have straight edges. The polygons are joined at the sides. It's a closed figure. Just like the polygons are closed figure, the polyhedron will be closed figures. So you won't have any sides that don't have anything there. Put that on there. And they share vertices. The polygons share vertices. So here's an example of a polyhedron. Okay. The faces are the polygons that make up the sides. So this whole triangle here would be a face. They're also known as bases. So the word base and face in a polyhedron are interchangeable. The edges are the lines where the two sides share an edge. I mean, that kind of makes sense, right? And then the vertices are all of the corners. So all the points. Edges. Now, this particular one is a hexagonal pyramid, and I'll tell you guys how to do the naming of these in a minute, but I just want to show you some examples in like 3D that we can't record. But okay, so a prism is a polygon with two parallel congruent bases. So if we were looking at this rectangular prism, the top and the bottom will be congruent, and those will be considered the bases in this case. And then they're connected with parallelogram faces. And now a parallelogram, when we think of a parallelogram, a lot of times we think of this shape. But a parallelogram can be a square or a rectangle as well. So you've got those kind of three shapes, which I didn't draw them very pretty. Let me cheat. Actually, it's not cheating. It's using technology. There. Okay, so it's cheating a little. Okay, and then a pyramid is a polygon or polyhedron that has a polygonal base, and this can be any polygon. So square, rectangle, a hexagon, a heptagon, pentagon, octagon, anything, any polygon with faces that come up that meet at a common vertex. So like this one that I showed you, this is a square pyramid because it has a square on the bottom, and then you have the triangles coming up. Things that are not polygons can be a cylinder. A cylinder does have a definition, though. It's a solid with congruent circular bases connected with a curved surface. And if you were to cut them out, the curved surface is a rectangle on a cylinder. So basically it's two circles connected with a rolled up rectangle. You have a cone, which is another solid. And a cone is kind of just basically a rounded pyramid. But if you think of like a waffle cone, you'll never forget the shape of a cone, right? We're very familiar with cones. We have had ice cream at some point, I'm sure. And then you have a sphere, and a sphere has a very, very specific definition. It is a set of points in space that are the same distance from a given point. Remember I told you guys that the definition of a circle was the set of points on a plane that were equally distant around from a center point, and that point kind of makes like, those points kind of make like a line, but really it's just points. Well, a sphere is the same definition, but instead of being on a plane, we're three-dimensional. So you have all of the points all the way around the outside of some central point. And a sphere is special in that it has no edges, no vertices, and no faces. Okay, so even though the cone and the cylinder aren't technically polyhedron, they do have edges and faces. The cylinder doesn't have any vertices, but it does have two edges and three faces. And then a cone has one edge and one vertice, and then still has faces. So, that's kind of the difference between those. The sphere is very special because it has none of those things. All right, to name a polyhedra, you name them based on the shape of their bases. Okay, so for example, if I had some polygon that had like two triangles like this and then connected, this would be a triangular prism. Or if I have, a box, that's a rectangular prism. I could have like a pentagon. Okay, I don't draw these very well, but you get the idea. It's like two pentagons with space. That would be a pentagonal prism. And so on and so forth. You can have trapezoidal prisms, quadrilateral prisms. You can have, octagonal prisms. Just whatever the shape is on either side, that's the name of the prism. And then with the pyramids, it's, if I have a triangle that comes up, I can't draw that very well, but you get the idea. There's a triangle with points coming up, then that's a triangular prism. Or if I have a square with the points coming up, it's a square prism. You can have a pentagonal prism, a rectangular prism, or pyramid. Why am I writing prism? I meant pyramid. I can't spell. Pyramid. My ancestors would be so mad at me. Okay, so rectangular pyramids, square pyramids, triangular pyramids, basically whatever the shape the bottom of the pyramid is, that's the name. So hexagon, right? A bad hexagon, but still it's a hexagon. So you'd have a hexagonal pyramid, and so on. Where we're going to identify the solid, we're going to say, okay, first of all, is it a polyhedron or not? If it is, we'll name it, and then we'll identify the bases, the faces, the edges, and the vertices. Okay, and we're going to differentiate between bases and faces, that the bases are like the bottom and top if it's a prism, or just the bottom if it's a pyramid. Okay, so yes, this is a polyhedron. Okay, it is a rectangular prism. Now we need to decide, in a rectangular prism, you have multiple options for bases. You just decide what's the top and the bottom. Because with a rectangular one, all of the opposite sides are going to be congruent because it's a rectangle. Like, so this side is congruent to that one, the front is congruent to the back, and this one's congruent to that one. Does that make sense? So with a rectangular one, you have a choice on which ones you decide are the bases. So do we want the big ones to be the bases, or the top and the bottom? The big ones? Okay, so our bases will be, now here's what you do. If I start here, I can either go SRQT or STQR. All right, what I don't do is I don't go SQR, we go around the outside. So I can say SRQT. So you just go around the outside when you're naming the polyhedron. You don't just randomly go wherever. You just follow along the outside. You can go either direction, just around the outside. And then if I start with N, I can go NMPO, or I can go NOPM. Yeah, the two bases. E? No, that's an R. Sorry. Okay, then the faces are the sides I chose or didn't choose to be the bases. So I have this rectangle up top and the rectangle on the bottom. So I'll have RMPQ and SNOT. That's kind of funny. And then I have the front and the back, so QPOT and RMNS. Now it doesn't matter what letter you start with, and it doesn't matter if you go around to the left or around to the right. Just pick a corner and then go around the shape. You just can't go out of order once you pick one. You have to go around it, the edges. Okay, so those are the faces and the bases. My edges are actual sides and they're segments, so I have to name them as segments. So for example, I'm naming this face RM. So I have to put a line over it because it's a segment. MP, PQ, QR, and then normally I just go around the top and then I go all down the bottom or the side, so I have RS, MN, PO, QT, and then the bottom edges, so SN, NO, OT, and TS. So those are all of the edges. And then we have the vertices. And those are just letters. So RM, P, Q, O, T, S, N. All of the corners. Do the next one. So the bases on the prism, first of all, this is a polyhedra because it's all made of polygons. So we'll say yes. And we have two triangles with rectangle sides. So this is a triangular prism. This is also one of the major shapes for an actual prism that bends light and gives you a rainbow. You either get this shape or that shape for those prisms usually, but this is probably the most common. So we have a triangular prism. Now the bases have to be the two congruent sides that are parallel to each other. That has to be the triangles on this one. So the bases are the triangles. So I have RPT and SQU. And it doesn't matter, again, which order, which letter I start with or which direction I go, as long as I go around the outside. My faces are the rectangles. So I have P, Q, U, T. P, Q, S, R. And then R, S, U, T. I have my edges, so I have the edges that go along between the two triangles. PQ, TU, RS, and then I have the edges of the actual triangles themselves. Yes. Okay, and then SQ, SU, and QU. Okay, so we've got the vertices, we've got the edges, the faces, and the bases, and are there any questions? Is this a polyhedron? No. I can name it, it's a cone, but I can't name faces and edges and vertices and all that because I'm not doing that. It's not a polyhedron, so you don't have to do that. You only have to name those if it is an actual polyhedron. Okay, is this a polyhedron? Yes. It is a triangular pyramid. The base is the bottom of the pyramid, so ABC. The faces are the triangles that come up, so you have DAC, DCB, and DBA. Your edges are, all the line segments. So I have AB, BC, AC, that's along the bottom. And then I have all the ones going up. So BD, CD, and AD. And then the vertices are all of the points. So A, B, C, and D. So no, it's not a polyhedron, it's a cylinder. And polyhedron? Nope, it's not a polyhedron, it's a sphere. Easy enough on those. Those take up no time at all. Okay. We have what's called a regular polyhedron. Just like we had a regular polygon, you can have a regular polyhedron. And a regular polyhedron is all faces are congruent regular polygons. So for example, if your faces could all be squares. Or your faces can all be equilateral triangles. Or regular pentagons, they have to be the same. All the sides, all the edges are the same length. All the angles in the polygons are the same. Okay. And what you get are 5 of them. That's it. There's only 5 in the millions of possible polyhedron that can be made. Actually, it's probably more than millions, but there's a lot. There are only 5 regular polyhedron. And these are called the Platonic solids, and they're the Platonic solids because of Plato. Okay. And this is them. And their names. So you have the tetrahedron, has 4 faces and they're equilateral triangles. Okay. Your octahedron has 8 faces that are equilateral triangles. So basically it's 2 square pyramids stuck together, top to bottom. Do you see that? You have a cube, which has 6 faces, and they're squares. You have the isosahedron, which has 20 faces, and they are equilateral triangles. And then the dodecahedron has 12 faces, and they are all regular pentagons. Dodecahedron is very kind of similar to a soccer ball in look. A soccer ball is not a dodecahedron. It has more of the shapes in that, and they're curved, so it's not even a polygon, but it sort of looks like that. Okay, so surface area and volume can be calculated. Now, surface area is the sum of the areas of all of the faces. Okay, and then volume is the amount of 3D space surface area is going to be in square units. Volume is going to be in cubic units. Okay, so surface area is literally the amount of squares that will fit over the whole surface of the object, and volume is the amount of cubes that would fill up the whole object. Okay, now we have T is what they're calling total surface area. So these are the surface area formulas. And then these are the volume formulas. Okay, so we have the surface area of a prism. You've got the perimeter times the height. That is one way to do surface area. And then 2 times the B, where that's the area of the base. But that's not the only formula for surface area of a prism. You can also do 2 times the length times the width, 2 times the length times the height, 2 times the width times the height. Basically, you're finding, okay, if this is height and this is width and this is length, you're finding the area of this rectangle by doing 2 times, or you're doing length times height, right? To find the area of that rectangle. Well, there's 2 of them, one in the front and one in the back. And then you find the area of this rectangle by doing width and height. Well, there's 2 of them, one here and one here. And then length times width gives you the area of this bottom rectangle, but there's 2 of those also. So that's the other way you can find it. You find the 3 sides basically, and multiply by 2 on each of those. Your regular pyramid, L is what you call the slant height. That's the height of the triangle on the side. And then you have the perimeter of the square, and then the area of the base. For a cylinder, you have 2 times pi times the radius times the height. That gives you the area of the curve around the outside. And then you have 2 pi r squared. That gives you 2 circles, because a circle is pi r squared. A cone, you have a slant height again, and then you have a regular height. So you have pi times the radius times the slant height, And then you have pi r squared for the circle. And then in the sphere, you have 4 pi r squared. And then for volume, you have the area of the base times the height, or you can do length times width times height, which I personally think is easier to remember. And then here you have 1/3 base times height, and height would be going straight up and down. And that's area of the base, so that's length times width times height again, but it's 1/3 of it. Here you have pi r squared height, 1/3 pi r squared height, and then the volume of a sphere is 4/3 pi r cubed. You'll need these, yes. You need to write these down. Or you'll have to look them up later. You need them, though. I learned, and so that's the one I'm really comfortable with. So it doesn't matter which one I call the length and the width and the height. It's just, you just name one of them, length, width, and height, because really it depends on how you're standing your box as to which one is the height, right? So if I stand the box this way, that's the height, but if I stand the box this way, that's the height. So it doesn't matter which is which. Just name one L, one W, one H. So I'll do 2 times 2 times 3 plus 2 times 2 times 6 plus 2 times 3 times 6. So that gives me 2 times 6, which is 12. 2 times 12, which is 24, and 2 times 18, which is 36. 36 and 24 is 60 plus 12, so that's 72 square feet. Okay. The volume is length times width times height, so 2 times 3 times 6. So 6 times 6 is 36 cubic feet. All right, you can kind of, there's a dotted line going down here. Can you guys see it? It's kind of faint. That's the height. Okay, and then this is the slant height. And then that's the base. And so our surface area was 1/2 the perimeter times the slant height plus the area of the base. So I have 1/2 of the perimeter. The perimeter is going to be 32 times 4, right? 4. Good. Times the slant height, so times 34. Plus the area of the base, which is going to be 32 times 32. So I'm going to cheat. So 32 times 4 times 34 divided by 2. So that's that number. And then 32 squared. So that's 3,200. And then volume is 1/3 base times height. And that's the area of the base. So 1/3, I have 32 times 32. That's the area of the base times the height, which is 30. And what I'm going to go ahead and do is I'm going to take 1/3 of 30, because 3 goes into 30 10 times. And that makes my math easier. So I'll do 32 times 32 times 10. And that's cubic inches, and this was square inches.